Okay, guys, we are going to discuss about this paper number 2. Yeah. So here we have a periodic table. Okay, and then they have given the alphabet and so on. We are going to write the electronic configuration of element Y. Okay, so in order to do that, okay, there are two ways. Yeah. So if you know your periodic table, okay, we know that hydrogen we don't write over here is going to be hydrogen 1. So this one is going to be helium. Okay, 2. Okay, then this is going to be lithium and so on. 3, 4. 5, 6, 7, 8, 9, 10, and 11. If you know that, okay, you can use this 11. Okay, so 11 electrons. So how do I write? Okay, I can write down as 1s2, 2s2, 2p6. Okay, now if I total up that, it's going to be already going to be 10. So I need another one more. Okay, so it's going to be 3s1. Okay, so this is going to be the answer. Now, if you don't want to use that, okay, there is another method as well, okay, which is using your blocks. Okay, so this one we know that, okay, S block, this is going to be your D block, and this is going to be your P block. Okay, so if you look at this S, okay, so this one is going to be 1s1, 1s2. So of course this one, okay, will start with 2s. Okay, so this one, okay, we just put it as 2s. Okay, this is going to be 3s and so on. Okay, and then this is going to be 4s. Okay, but this one, when we start, it's supposed to start from 3d. Yeah, so this one, if you know how to use them, okay, then it's going to be very useful. Okay, so here, okay, if I straight away use this method, okay, this one, I know this is 3s1. Okay, this will be 3s2. So it means it is ending at 3s1. So I just know that it will end at 3s1. So I just need to fill up the rest. 1s2, 2s2, 2p6, and then 3s1. So you will get the answer. Okay, there are two ways of doing this. Okay, so if I write down, let's say, for example, we learn, yeah, so let's learn. Okay, if I want to write down how to write the electronic configuration for X, for example. Okay, so I know that this is going to be 3s1, 3s2, so even 11, 12, this is 13 supposed to be. Okay, so I know 3s1, 3s2, then after that, it's supposed to start with after 3s2, okay, you are going to start with 3p. Yeah, so this one is also going to start from 3p. Okay, so if I just put over here, this is 3p1. Okay, so if I want to write down for X the electronic configuration for X, okay, it's supposed to be ending with 3p1. So how do I write? 1s2, 2s2, 2p6, 3s2, then only we go to 3p. So 3p1. Yeah. So this is how you write the electronic configuration. Yeah. So let's move on. Okay. Describe and explain the difference of the atomic radii of X and W. Now, if you look at this, okay, this is going to be from group 13, okay, group 13, 14, 15, 16, okay, group 16. And we know that when you go across, okay, the periodic table, we should know that, okay, the size is going to become smaller. Why? Because, okay, we are going to have the same period, the same number of periods means you are going to have the same number of shells, which is going to be the shielding is constant. Now, if the shielding is constant, okay, because the number of shells are the same, okay, but we know the proton number is increasing. Okay, when the proton number increase, okay, and the shielding effect is going to be constant, your nuclear charge, therefore, is going to be getting stronger. Okay, so this nuclear charge, okay, is going to able to have a better, stronger attraction towards the electrons and making them more closer to the nucleus. Okay, therefore, okay, we know that W is going to be smaller, okay, compared to X. So if I put it visually over here, X will be bigger, W will be smaller. Yeah. So describe and explain the atomic radii. So you write down, okay, we write down that, okay, your atomic radii, okay, atomic radii of radius, okay, atomic radius for atomic radius for W, okay, is smaller than atomic radius of X. Why? Okay, because okay, going across the periodic table, the number of shells are the same. So shielding effect, okay, shielding effect is constant. Okay, okay, you write down, okay, in full. Shielding effect is constant, and then okay, the proton number, okay, proton number increases, okay, going to the right. Okay, therefore your nuclear charge, okay, nuclear charge, okay, is going to increase. Okay, so this increase in nuclear charge makes okay, the attraction, okay, attraction of the nucleus, okay, or nucleus, nuclear attraction, okay, towards the electrons in W, okay, is going to be stronger, okay, compared to X, okay, making the radii, okay, or the making the radius of atomic radius of W, okay, smaller than atomic radius of X. This is the explanation, and this is for 2 marks. Now, write an equation, okay, to show the first ionization energy of Z. Now, if you want to show first ionization energy of Z, okay, it is going to be removing 1 electron from Z, yeah? So you remove, okay, remove 1 electron. So when you remove 1 electron, so we don't write it like minus electron over there. Okay, so it's supposed to be you remove, so they will become Z positive. Okay, so here, okay, in chemistry, we don't say minus electron, we bring it to the over here. So it's going to be plus electron over here. Okay, so do remember, if you answer like this, okay, you will get 0 mark. Because, okay, in order to write the first ionization energy or any ionization energy, okay, you need to make sure that the removal is going to form, you are removing the electron in form of gas, and the ion that you get must be in gas. Okay, this is very, very important. Okay, now next is going to be the following graph shows the melting point, okay, trend of the oxide of period 3. Explain the melting point of period 3 oxides based on their structures. So here, okay, we can divide them into 3 parts. Okay, I can divide them maybe here, okay, and I can divide this SiO2 as 1 part, and I can divide this into this. Okay, what can I say about the melting point of this NaMg and Al? Yeah, the oxide of this. Okay, all of them are going to be metal oxides. And metal oxide, group 1, group 2, group 3, metal oxides, they will form a giant ionic lattice. Okay, this giant ionic lattice, okay, will make the boiling point and the melting point higher. Okay, so that is going to be one of the reasons. Now, you no need to explain, okay, why the trend, yeah, so Na2O compared to MgO is going to be higher and so on. Generally, it's because of the structure, yeah, but you can see, okay, that they are generally going to be higher. Okay, so you can see sodium oxide, except for sodium oxide, magnesium oxide and aluminum oxide, they will have higher melting point. So giant ionic lattice, you mentioned about that. And for SiO2, you need to mention this is going to be a giant, okay, covalent structure. Okay, so this is also considered to be a high melting point. Okay, so you explain about that. And the last part that you need to explain for P4O10 and SO3 is going to be they are simple molecular or simple covalent molecule. Okay, so simple molecular structure. Okay, so you just mention about this and you should get the 2 marks. Okay, so what you need, okay, you need to tell. Okay, so Na2, okay, Na2O, MgO, and Al2O3. Okay, they have giant ionic lattice. Okay, therefore, okay, the boiling point and the melting point. In this case, they mention about melting point. Okay, therefore the melting point is higher. No need to differentiate. Yeah, no need to tell why Na2 is a bit lower. No need. It's actually, if they ask also, they are not in your syllabus. If they ask, okay, then you need to know it's going to be related to the structure. It's not that important. Okay, so you just need to explain about that. The second part that you need to mention is going to be SiO2. They are going to have giant covalent structure. Okay, and this giant covalent structure is also going to contribute to higher melting point. And the last one is going to be P4O10 and your SO3. They are going to be simple molecular structure. So simple molecular structure, they are going to have weak, okay, forces of attraction. Okay, so therefore, okay, they are going to have lower melting point. Okay, so you just explain about that. Okay, once you mention about this, okay, then any of these three, yeah. So if you mention two statements over here, you will be given 2 marks. Okay, that's it for this. Now, see, calcium is a very soft silvery metal at room temperature. It has 6 known isotopes. Okay, it has a variety of compounds used in many applications. Okay, so we want to know what is the meaning of isotope. Yeah, so what is isotope? Okay, isotope is the element. Okay, it's the same element. Okay, it's the same element. Okay, so like in this case, calcium, it's the same calcium. Okay, it's the same element. Okay, but you say with, okay, it's going to be the same element with the same, if the same element means they have the same proton number, with the same proton number, but different neutron number, okay, or different number of neutron, or you say different number of nucleon, okay, different nucleon number. Okay, it is acceptable, okay, if you write down, okay, they have the same number of proton, okay, but different mass. Okay, so it's okay. But if you want to write down, I think in a proper way, then it's going to be having the same proton number, okay, but different nucleon number or different number of neutron. Yeah, then it's okay. Yeah. Now, calcium carbide is produced from the reaction of calcium oxide and carbon. Okay, they say calcium oxide, okay, calcium oxide with carbon, they produce calcium carbide. Okay, another product is carbon monoxide. So you just need to write a balance equation. Okay, so how do I balance this? Okay, you can see carbon here, 2 carbon and 1 more carbon. You just put 3 carbon over there. And then oxygen, everything is balanced. Okay, so that's it. I think quite simple. Okay, some of you didn't look at it properly and you balance it wrongly. Okay, so this one is important. Okay, another thing that you need to write down, okay, you always check, yeah, whether it's 1 mark or what, if you can come up with the state. Okay, so you write down the state. Okay, like say, for example, this is solid, okay, and then this one is solid, not sure, calcium carbide, okay, solid. Okay, this one is going to be gas or something like that. Yeah. So just, okay, if you have 2 marks compulsory, must write the state. 1 mark, maybe they're flexible a bit, okay, but do not take any chances. You can see if you took chances over here, okay, you don't give this gas, you will get 0 mark. Okay, so be very careful. Don't take any chances. Yeah. Now, state 1 use of calcium carbonate. Now, 1 use, I think the common use is going to be in raising your pH of the soil. Okay, raising pH of soil. Okay, but some of you actually give some other answer. Okay, like use in fertilizer, providing calcium uptake by plants. Okay, manufacture of cement. Okay, so if you put something to do with the building material and so on, okay, it's okay, we will accept. Okay, but here, I think one of the common use of calcium carbonate is going to be raising pH of soil. Yeah. Now, D. Silicon is the second most abundant element, yeah, after oxygen. So the most common compound is going to be silicon dioxide. So it's going to be SiO2, the main component of sand. Yeah. Describe the bonding and structure in silicon dioxide. Yeah, just now I mentioned about Okay, silicon dioxide just now, they have a giant covalent structure. So if you have that, I think you just put it over here, the bonding and structure. What is the structure? SiO2, they have giant giant covalent structure. Okay, giant covalent structure. So you extend by saying that each of them, okay, in this case, silicon and oxygen are bonded, okay, covalently, okay, are bonded covalently, okay, or are bonded with strong covalent, okay, with strong covalent bonds. Okay, you just write down. Yeah, that's going to be another point. The last point is you just mentioned about each. Okay, each Si is bonded to 4 oxygen atoms. Each oxygen atom, okay, is bonded to 2 Si atoms. Okay, you need to know this. Okay, so if you have this, okay, then you just need to select any of these 3 and then you will get the marks. Okay, so giant covalent structure, okay, and then bonded with covalent bonds, or you just mention about this or this, okay, they will give you the 3 marks. Okay, so any 3 from this suggested 4, okay, statements. Now, solid silicon dioxide must be reacted in 1:2 ratio. Okay, this one. Okay, most of you miss out this. Okay, they say 1:2 ratio with sodium carbonate. Okay, so you see SiO2 reacted with sodium carbonate. Okay, this is equation for sodium carbonate. And then they say 1:2. Okay, so normally we don't put the 1. I'll remove the 1. And then they say the reaction, okay, they form salt A, something, okay, and a colorless gas B that turns lime water milky. Come on, you need to know carbonate. Okay, carbonate with SiO2. SiO2 is an acidic oxide. Acidic oxide, when you react with sodium carbonate, they will give you carbon dioxide. So this one you need to know, yeah, carbon dioxide. So this one straight away, okay, they say A is salt, okay, B is going to be the gas, so carbon dioxide. Okay, I put carbon dioxide as B here. So what is A? Okay, this is going to be the part that you need to remember about the ratio. Yeah, so here I have 1 Si, 2 Na, and then you have 2 carbon. Okay, so we know that, okay, there is going to be 2 carbon. I just put 2 there. Okay, I put 2 there. And then what is the salt? Okay, of course the salt must have something with Na. Okay, must have something with Si. Okay, and must have something with O. Okay, so must have something with O. I just put over there. But how many? Yeah, so that is important. So here I have 4 atoms of, okay, 4 moles of Na. So I just put 4. Sorry, I just put 4 here. Si, okay, I have only 1. Okay, put 1. Oxygen, I have 4 oxygen here. Okay, 4 oxygen. How many oxygen that I have over here? 2 oxygen. And then I have 3 times 2, 6 oxygen. So I need to have 2 plus 6 is 8. Okay, so if I have 8, okay, here I have 4. So I need another 4 over here. Okay, so that is why, okay, the answer over here will be, okay, if I change the pen, okay, it's supposed to be Na4SiO4. Okay, most of you would have answered NaSiO3, not accepted. You must follow this ratio because we are talking about the ratio of 1 and 2. You just need to follow the question. Yeah. Now, sulfur dioxide is emitted into atmosphere, okay, when sulfur containing compounds are burned. Yeah. So it reacts with water, okay, it reacts with water in air, producing a weak acidic solution. Okay, this weak acidic solution dissociate in water, and it's a reversible reaction. They already mentioned this. Okay, so write the dissociation of this acid in water. Okay, so we need to write down the dissociation of this acid in water. So how can I write down? Okay, so first you see sulfur burn, so you get sulfur dioxide. Sulfur dioxide, when they react with water, okay, they are going to give you this H2, okay, SO3. Okay, this is going to be the sulfurous acid. Okay, so this one, okay, this weak acid dissociate in water and reversible reaction. So H2SO3, okay, if they dissociate in water, you write down like this. Okay, it's going to be dissociate like this, and it's a reversible reaction. Don't dissociate completely. Writing down 2H plus and SO3 2 minus is wrong. Okay, it is going to be weakly dissociated. You remove only one H, and then the remaining H SO3 minus, leave it over there. Include state symbol. Yeah, include the reversible sign. If you don't include this, you are going to be marked wrong. This is aqueous, this is aqueous, and this is aqueous. Now, what if, okay, which I don't see any one of you from put the this equation, but if you write down in this manner, the reaction with water, okay, so it's supposed to be H2SO3 plus water. If you want to show like that, also can. Okay, but you need to write down H3O plus, okay, and then, okay, this one is going to be HSO3 minus, okay. It means the H plus, okay, will join, okay, with the water molecule, okay. It will join with water molecule to give you hydroxonium ion, okay. So therefore, okay, it is not complete. So you must put aqueous. This one is liquid. You must put aqueous. You must put aqueous. Okay. So if you write that down, okay, it means this is also correct. But most of you answer in this way. Yeah. Please take note. Now describe one environmental consequence, okay, of the presence of sulfur dioxide in atmosphere. Okay, because just now in the previous example, we know that you are going to get SO3. Okay, when you are having SO3 in atmosphere, okay, what will happen? Okay, so generally when you have SO2 or SO3, okay, when you react with water, okay, they will give you H2SO3. So this one, H2SO3, is going to be something related to acid rain. Okay, so you can write down acid rain. Okay, but you need to describe, even though it's going to be 1 mark. So acid rain can cause, okay, can cause what? Okay, they can make the aquatic plant, okay, aquatic plant or aquatic animals die. Yeah, so you can say that, or you can say that it can also destroy buildings, okay, because the limestone buildings, the buildings that is made from limestone, okay, can be eroded. Okay, so destroys building, okay. Or you can say that they will kill aquatic plant, okay, aquatic plant or animals, okay, plants or animals. So you need to explain. Okay, some of you just put acid rain. I did accept. Okay, but in future, read the question properly. Describe. You need to describe. Yeah. Further reaction of sulfur dioxide with oxygen. Okay, they form sulfur trioxide. Okay, so it means further. Okay, they will have the SO2 plus O2, they are going to get SO3. So this one, if I balance, is going to be something like this. This is a key step in the contact process. Okay, do remember, contact process, this is a reversible reaction. You can see they already put the equation over there. And they mentioned it's going to be exothermic. Describe and explain what will happen to the equilibrium position if the pressure is decreased. Now, when we are dealing with pressure, we need to look into the number of molecules of the gas. So 2 moles over here, 2 and 1, 3. So when you decrease the pressure, according to your Le-Chatelier's principle, okay, you need to try to increase the pressure. How do you try to increase the pressure? By shifting the position of the equilibrium towards more number of molecules. So in this case, it's going to be from 2 to become 3. So they are going to favor the reverse reaction or favor the backwards reaction. So I'm looking into position. You explain. The position is shifted to the left. Shifted to the left. And I have mentioned to you many times that you need to mention it is shifted to the left to favor more molecules, to favor more molecules or to favor more number of moles, more number of moles. So of molecules, up to you. Explain. As long you mention shifted to the left and to favor more molecules or more moles, then you will get the full mark. Next. So this one is going to be something to do with nitrogen. They are asking about explain why nitrogen is unreactive. Even though it's 1 mark, most of you didn't really answer it properly. You just need to tell that nitrogen is bonded, with triple covalent bond. Nitrogen and nitrogen, they have triple covalent bond or triple bonds. So nitrogen has triple covalent bonds. And these triple covalent bonds, they will be difficult to be broken. And you need to explain why. Why difficult to be broken? Because the activation energy required or the bond energy required to break the triple bond is going to be too high. So the activation energy required to break the bond, is too high. It's high. So as long you mention this, then you're good enough. You can get that 1 mark. What type of bonding is happening in sodium azide? Very easy question. Sodium is metal. Nitrogen is going to be non-metal. There shouldn't be any different answer. What type of bonding? Ionic bonding. Ionic bonding. Now, so ionic bonding is the bonding between metal and non-metal. So now we need to complete dot and cross diagram for the azide ion. Do remember extra 1 electron coming over here. So whenever you have this, you need to know nitrogen will have 5 valence electron because group 15. So from this 5 valence electron, how do I show is going to be negative ion? So this one you need to be very careful. So in order to do that, I will suggest to think in this way. Nitrogen, I have 3. So if I want to put, I know in the center, always start from the center. In the center, I need to have 5 valence electron. I will just need to share, left and right. And I will always think about sharing equally. Share equally. So if I'm sharing equally 5, how to share equally? Maybe 2 electron I put over here, 2 electron I put over there. And then I have 1 more electron over here. But I need to make sure, if I share 2 electrons, the 2 electrons also must come from the nitrogen on which I'm sharing. Another 2 electrons will come over here. So it means that they supposed to have, each of them supposed to have 3 electrons over here, 3 electrons over here. But now I need to figure out about the charges. So if it is going to be, if I want to make them to have -1, it means there is going to be additional 1 electron. Additional 1 electron. So where do they come? So the additional 1 electron, how to get this done? The only way that I can think of is you remove this, make this as positive. So it means if you make this positive, it means you are removing this electron. So it means that's why they have 4 electrons. So this is positive. So if I want negative overall, you cancel with one of it, negative. It's neutral. So if it is negative over here, there will be another 1 more electron over here, right? And then you want overall everything to be negative. Okay, this is neutral. So this one you must have negative, then only they will become negative. So it means one more electron comes over here. So now we just need to replicate and put everything together properly. Okay, so how? Okay, you just need to show 4 electrons here. Okay, so here I will put x dot dot. Okay, so the dot is coming from the central atom, so x is okay. Okay, and I know that this is positive, so therefore there is no any electron in the middle. Okay, and then this, okay, I'm going to put 4 electrons here, 4 electrons over here. So I know that, okay, this one must be x here, so I just put x, okay, and then x. Okay, so I know that, okay, each nitrogen have 5 valence electron. Yeah, 5 valence electron. Okay, and then, okay, you are going to get, okay, one of the electron, okay, one of the electron is going to come from maybe outside. So maybe I'll just put like this. Okay, this is coming from outside. And then here, okay, is going to be also, okay, 4 electrons. So I just put x, okay, x, okay, and you see that, okay, they have supposed to have 5 valence electron. Okay, so one more electron. Are they coming from outside or they are coming from inside? Okay, my answer is it's coming from the nitrogen here itself. Okay, so here, okay, in this case, I'll just put it as, okay, because only one electron is coming from outside. Yeah, so this one. So I can just put, okay, that this electron may be coming from here. Okay, I just put one dot here. It's okay. You can put it over there. Or, okay, if you wondering why suddenly from this one dot come over here, if that is confusing, it's okay. We can remove this. Okay, we can put the dotted electron here. Okay, and then we can put, okay, this one over here. No problem. Okay, so anyway, okay, this is supposed to be how you draw. Yeah, there will be 2 double bonds. Okay, and then if you look at it, okay, the nitrogen in the middle have 8 electrons. Nitrogen over here has 8 electrons. Okay, and nitrogen over here has 8 electrons. They are positive here, negative, negative. Total charge is going to be -1. Okay, this is how you get them sorted out. Yeah, so this is the cross and dot diagram for azide ion. Now next, okay, NOx gas are produced from the reaction of nitrogen and oxygen, okay, in the atmosphere, okay, at high temperature. Yeah, describe and explain the role of nitrogen dioxide in the formation of SO3. Okay, from SO2. Yeah, so they have already given you some hints over there. So you are reacting nitrogen dioxide, you are reacting with SO2, and you are forming SO3. So in this case, what is the role? Yeah, the role over here, okay, most of you answered catalyst. Okay, there is another answer which is also accepted. Okay, so I will discuss in a while. Okay, plus, okay, so what will happen? Okay, so if this one, the oxygen went over there, so this one must be NO. Okay, so it's balanced. So in this case, we know that the oxygen is going out to, is given to SO3. Okay, it means that when you remove the oxygen atom, this is going to be reduced. Okay, so this is reduced, and we know that this is oxidized. So this one is a redox reaction also. So if you want to write down, instead of catalyst, I want to give a different answer. Okay, what is the role of NO2? You can write down oxidizing agent. What is going to be the definition of oxidizing agent? Oxidizing agent is going to be an agent, something that will oxidize others. You see, NO2 is oxidizing SO2. Okay, something that will oxidize others, but at the same time, they get reduced. Okay, they get reduced. Okay, so we do accept, okay, the answer if you have written oxidizing agent. Okay, next. So you have this N2O is also known as laughing gas. Okay, so this one is going to be the laughing gas. Okay, so they say that it can be produced, okay, by using heating ammonium nitrate. Okay, it decomposes into nitrous oxide, okay, and water vapor. So they have given you the equation. Okay, sketch an energy profile diagram. Yeah, do remember decomposition. Decomposition is always endothermic. So if you want to sketch an energy profile diagram, so this one will be energy. Okay, this one, okay, if it is going to be profile, no need to write anything. Yeah, so this one is going to be make sure to show that this is going to be an endothermic reaction. So you draw like this. Okay, so you can put, okay, this one is going to be NH4, okay, NO3, and the product that you are going to get is 2H2O, okay, plus N2O. Okay, that's going to be a product. And then there is no other information over here. They say that label your diagram. I've already labeled. If you want, you can just write down progress over here. And then if I want to show the activation energy, it's going to be from the bottom all the way to the top. So this is the activation energy. And then you need to also write down maybe here, I'll just put down from here to here. This is also going to be your delta H is going to be positive. It's an endothermic. If you want to write down that, yeah. So this is going to be the actual answer, yeah. Now you have, okay, this Haber-Bosch process. Okay, you have 3 steps. Work out the enthalpy of reaction for the forward reaction in step 1 using bond energies from data booklet. Okay, so we need to write down, okay, for step number 1, okay, and then we need to use the data booklets data, yeah, so the bond energies from there. So here, okay, I have CH4. I can just put it over here, CH4, okay, plus H2O, okay, and then when I have this, okay, 3H2, it means I can separate this into 2, yeah. So this is going to be your bond breaking, okay, your bond breaking, and this is going to be your bond formation, okay, bond formation. So when I have this, okay, I need to look for the bond between the carbon and hydrogen, okay. So carbon and hydrogen, CH4, I have 4, okay, bonds between carbon and hydrogen. So 4 bonds between carbon and hydrogen, I need to add, okay, with water, okay, HOH. 2 bonds between, okay, O and hydrogen. Okay. And here, okay, I need to look for bond between carbon and oxygen. Okay, so this one is supposed to be the bond for the carbon monoxide. Yeah, so carbon monoxide is going to be something like this. And then this is going to be U plus with 3 hydrogen. Okay, hydrogen. So hydrogen and hydrogen, 3. Okay, so I'll just quickly look at the data booklet. Okay, I'll get the data booklet values. Okay, so if you look at the data booklet, okay, I will need to go and look for the bond energies at the beginning. Yeah, so here I'm looking at, okay, so bond energies. Okay, if you look at bond energies, there are 2. Yeah, so you need to be very careful. Yeah, so one is going to be bond energies in diatomic molecule. Yeah, and there is going to be bond energies in polyatomic molecule. Okay, so be careful with those. Okay, so for example, CH4 is not diatomic. CH4 is going to be polyatomic. So you look for bond between CH, which is going to be 410. Yeah, so 4 times 410. And then OH, okay, this is going to be the bond between O and H in water. Okay, so O and H is going to be, hold on, okay, O and H is going to be 460. So 2 times 460. And then, okay, CO, okay, you need to be very, very careful over here. CO, carbon monoxide, is diatomic. Yeah, so you look at bond energies in diatomic molecules. Don't make that mistake. Yeah, so this one is going to be 1077. Okay, and then 3. So hydrogen H2. Yeah, so H2 is diatomic. So H2 is going to be 436. Okay, so be careful which value that you choose. Okay, so here I will just get your the calculator over here. Okay, so hold on. Okay, I'll get the calculator and then I put over here. Now, so if I put over here, if I want to calculate now, okay, so let's say, for example, 4 times 410, okay, 4 times 410, okay, I'm going to get 1640. 2 times 460, 2 times 460, 920. Okay, so my bond breaking is going to be total is going to be 2560. That's my bond breaking. And then my bond formation, okay, so it's going to be 3 times 436, okay, 1308. Then I will add with 1077. 2385. Now, do remember, this is bond breaking, this is bond formation. Always remember the final answer. Okay, I don't follow the formula and so on. Yeah, the final answer is going to be bond breaking is going to be positive. Bond forming is going to be formation of bond is always going to be negative. What you need to do if you want to find out the enthalpy change of reaction is going to be these two, you plus. Okay, so it means same this you plus with this. Okay, so it means you will have 2560 plus and minus is minus 2385. Okay, so if you do that, okay, you are going to get 2560. Okay, you minus with 2385 and you will get the answer as positive 175. Okay, so if you get different answer, yeah, please remember it's not going to be accepted. Okay, the unit also, please be careful, the unit is going to be kilojoule per mole. Okay, so I'll just put kilojoule per mole. Okay, 2 marks. Okay, all the other answers, okay, they are not accepted. Okay, so if you are those answers not accepted, now you should know why. Yeah, okay, now next. Okay, next is going to be, so now state the importance of step 3 in Haber process when the concentration of carbon monoxide is high. Now, when the concentration of carbon monoxide is high, okay, what they do in step 3, they are removing the carbon monoxide by changing it into carbon dioxide. Okay, they are asking why it is important. Okay, this is important, okay, because when you remove the carbon monoxide, this is going to be two reasons. One, okay, is, okay, when you remove the carbon monoxide, you are going to actually decrease the amount of carbon monoxide. So this is going to make the equilibrium to be shifted forward. Yeah, so when this equilibrium is shifted forward, you are going to increase the yield. Okay, but not only that, okay, carbon monoxide buildup, okay, will make, okay, carbon monoxide is toxic. Okay, so it will it is dangerous, so you need to remove it. Okay, so there are two importance over here. Okay, so you write down, okay, one is going to be carbon monoxide is toxic, okay, it's dangerous. So it is removed, okay, it is removed. And the removal of this, okay, will shift the equilibrium, okay, shift the equilibrium in step number 1, okay, equilibrium in step number 1, okay, to the right, okay, and this will increase the yield. Will increase the yield. And this is going to be 1 mark. Okay, you need to just write down. Now, next, a mixture of 80 moles of CO, 40 moles of H2, 40 moles of CO2 in contact with 80 moles of steam. Okay, was allowed to come to an equilibrium in a reactor of this, okay, and then Kp is given. Okay, calculate the moles of each gas leaving the reaction after the equilibrium. Yeah, so how to do this? Okay, so I remove the calculator first. Okay, now, so here, okay, we are talking about, okay, CO, hydrogen, and CO2. Okay, so coming in contact with 80 moles of steam. Yeah, so also water. So it means they are talking about, okay, step number 3. Yeah, so I'll just write down CO plus H2O, and they are going to give you CO2 and H2. So how do we do this? Okay, so this one is going to be by using the ice method. Do remember, okay, they are steam, okay, is going to be a reactant, okay, therefore they must be there, yeah, must be there in your Kp expression. So here a mixture of 80 moles, so here I'll just put 80, okay, assume that all of this is going to be happening in 1 dm cube container, yeah, so 80, yeah, you just put 80, and then 40 earlier, okay, and then 40 CO2, okay, and then water is going to be 80, yeah, so 80 over there. Okay, all this information are given, yeah. So we know that everything is going to be with the ratio of 1, 1, 1, 1, yeah. So it means that, okay, if there is a change, okay, then it's going to be minus x, okay, 1, yeah. So minus x, so plus x, okay. So if I'm looking into this equilibrium, yeah, so it's supposed to be 80 minus x, 80 minus x, 40 plus x, 40 plus x, okay. So we are looking into that. So here, okay, if I put the Kp, okay, 0.64, okay, Kp, this is going to be the, we are going to look into this partial pressure, yeah, partial pressure. So if I'm looking into this partial pressure, okay, I obviously need to look at my total pressure also, yeah. Total pressure is going to be, let's say I'm going to have P, okay, P is going to be my total pressure. So let's say total number of moles, okay, total number of moles is, you are going to add all this, okay. If it is going to be my total number of moles over here, okay, number of moles, okay, it's going to be, so you just add, okay, 80 minus x, okay, 80 minus x plus 40 plus x, 40 plus x. So what we will get, okay, so if you if I add, yeah, so I will get 160, okay, minus 2x, then plus 80 plus 2x, okay, the x will be gone, okay, so it's going to be, I'm going to get 240, okay, 240 is the total number of moles, okay. So here, okay, if I'm going to write the equation, okay, the equation is going to be 0.64, okay, for carbon monoxide, okay, 80 minus x, okay, divided by 240 times P, okay, that's going to be my partial pressure, okay. And then, okay, for, okay, let's, I think I made a mistake over here. Okay, now, if I just put, okay, here it's going to be 40 plus x, okay, divided by, okay, total, okay, so I'm looking for carbon dioxide, yeah, 40 plus x divided by 240, then times by P, okay. Then hydrogen, okay, hydrogen is going to be 40 plus x divided by 240, okay, times by P also, divided by 80 minus x divided by 240 times P also, and then 80 minus x divided by 240 times P. Okay, do remember, okay, This one is 1 dm cube. Okay, in this case, I'm just using the partial pressure. Yeah. So here, okay, you can eliminate. Okay, eliminate all this. I'll just use the red pen over here. This one, okay, will be cancelled with this. This one will be cancelled with this. Okay, what we will get is going to be. So here, okay, just now, okay, I'll just add some more. Okay, so if I want to continue, okay, so let's say 0.64, I'll write down 0.64, okay, equals to, if I cancel and so on, I will get 40 plus x to the power of 2 divided by 80 minus x to the power of 2. Okay, so I just need to square root, I'll get 0.8 over here. Okay, this is going to be 40 plus x, 80 minus x. Okay, so I just need to times. Okay, so if I have 0.8, okay, times 80, okay, minus x equals to 40 plus x. Okay, this one is going to be 64. Okay, and then minus 0.8x equals to 40, okay, plus x. So if I bring that, okay, to the right, 0.8, so it's going to be 1.8x. Okay, this one I bring to the left, 64 minus 40 is going to be 24. Okay, so what is going to be my x? X equals to 24 divided by 1.8. Okay, so what is 24 divided by 1.8? 24 divided by 1.8. Which is going to be 13.333. Okay, so I'll just put like this. So here, okay, they are asking you to calculate the moles of each gas leaving the reaction after the equilibrium. Yeah. So after the equilibrium, I just want to find out, okay, what is going to be the volume. So if I'm looking for okay, what is going to be the moles, sorry. Okay, so if I'm looking for that, okay, for carbon monoxide, okay, carbon monoxide is 80, okay, minus x. So 80 minus 13.33. Yeah, so 80, okay, minus answer. Okay, then it will give me 66.67. Okay, or I just change it to three significant figures, 66.7. 66.7. So same, okay, water is also going to be 80 minus x is going to be 66.7. Okay, for carbon dioxide, it's 40 plus x, so it's going to be 53.33. I'll just put 53.3. And then the same for hydrogen. Hydrogen is going to be 53.3 as well. Okay, so these are the answers, moles. Yeah. Okay, next. So titanium nitride, okay, is used to increase the hardness of titanium. Okay, so it also gives a beautiful gold color and so on. Not so important, yeah. So aside from the formation of this solid, okay, solid PIN, okay, what else can be visually observed from the reaction above? Yeah. So you see this, and you also see this gas. You also see this gas, but this gas is colorless. Okay. So I can already see this. Yeah, if it is going to be what else visually you observe, so you will get steamy white fume. Okay, so do remember HCl gas, okay, is going to be steamy white fumes. Okay, do not, okay, in this case, okay, what else can be observed and so on. Some students, yeah, they say, sir, okay, I write effervescence is gas, what? Okay, why effervescence is not accepted? Yeah, it's not accepted because you are reacting solid and gas. There is no liquid over there. So if you are having bubbles formation and effervescence and so on, okay, there's no water over there. How do you expect to see effervescence? Yeah, so the answer, effervescence, will not be considered. Bubbles will not be considered. Okay, we will only take steamy white fumes. Okay, and then what is the oxidation state, okay, of titanium in here? Yeah, so if you want to find out what is going to be the oxidation state of this, okay, quite simple also. Okay, this one, okay, is going to be from you just need to look at nitrogen is going to be from group 15. Yeah. So if nitrogen is going to be group 15, okay, they tend to form N3 minus. Yeah. Okay. So if it is like that, the oxidation state of nitrogen is going to be -3. So if I put X, okay, plus -3, okay, and then this is going to be equals to 0, X should be +3. Okay, so therefore, okay, the oxidation state of that is going to be +3. Okay, now name the compound, okay, that is going to be the oxidizing agent. Very easy concept, yeah. So you can see here, okay, just now the tin, just now I know this is +3. Okay, and then I can find out what is going to be this TiCl4. Okay, X plus 4 times -1. Okay, Cl is always -1, group 17. So X minus 4 equals to 0, X equals to 4. Okay, so this is going to be Ti is going to be +4. So I know from +4 become +3, so it's going to be reduced. Okay, so always remember what is being reduced. Oxidizing agent will oxidize others, but they themselves will get reduced. Reducing agent, they will reduce others, but they themselves will get oxidized. In this case, what is being reduced over here? TiCl4. Okay. So what is being oxidized over here? This one also, if you want to check, yeah, nitrogen, this is going to be 0. Okay, the nitrogen over here is going to be, you can put X, okay, plus hydrogen is always going to be negative, it's going to be always going to be +1. So it's going to be 3, so it's going to be, in this case, it's going to be 0, so X equals to -3. So from -3, they become 0, they are going to get oxidized, increase in oxidation number. Okay, so therefore, ammonia is going to be the reducing agent. Done, yeah? Now, complete the table below to give the formula and approximate pH. Very easy, okay, if you know, yeah? So aluminium, you can choose aluminium chloride, okay? Or you can also answer aluminium in this way, okay? Both also accepted. Okay, silicon, okay, this is going to be SiCl4, okay, so you need to answer that. Phosphorus, okay, there are 2 answers as well, PCl3, or if you answer PCl5, also accepted. Okay, do remember, okay, the pH, okay, that we are going to accept is going to be 1 to 2, 1 to 2. This one will be acidic, yeah, must be acidic a bit, okay, so therefore, okay, the answer key is 6.5, but I think 6, anything from 6 to 6.9, okay, maybe we will accept, yeah. So that is going to be must, as long it is not 7, you don't show it's 7, okay, it must be slightly acidic, yeah. Now, next, okay, boron trichloride, okay, is going to be a colorless gas with pungent odor. Yeah, another gas that is always pungent is ammonia. Yeah. So anyway, draw the shape and predict the bond angle of this compound. Some of you, yeah, if you write down drawing shape, okay, you do not need to show all the electrons. They just want to see the shape. Yeah. So boron is going to be, okay, boron is going to be group. Okay, just check. Okay, boron is going to be group 3. Okay, let me just quickly check. Okay, boron. Okay, if you're not sure, always check. Okay, always check. Okay, so boron is going to be group 13. Yeah, so it's 5. Yes, so group 13. Okay, so 3 valence electron. Okay, so if you have 3 valence electron sharing with 3 Cl, so you just need to show like this. Okay, there is no lone pair. Okay, so as long you show like this is enough already. Yeah, I do see some of you writing the cross dot diagram and so on. This is not a cross dot diagram. They didn't ask you to draw the cross dot diagram. Some of you went and draw something like this, okay, which is not accepted. Okay, please remember they are asking you to draw the shape, draw the actual shape, which shows that this is going to be 120 degrees. Okay, so the bond angle is 120 degrees. This is going to be, if they ask you to name it, trigonal planar. Okay, so please remember. Yeah, now bromine is another halogen. okay, when paired with chlorine, okay, you see Br2 is another halogen. When paired with chlorine, okay, when paired with chlorine, an interhalogen BrCl is formed. BrCl is formed. Its reaction, okay, so this one, if I balance, I just put over here. Its reaction with water, okay, so it produces, okay, let's say for example BrCl. Now when you react with water, it produces a strong and weak acid only, okay. So what is going to be the strong acid over here? Okay, do remember HBr and HCl, they are strong acid. So if you write down, okay, they produce HCl, and then you write down, okay, so this H and Cl, so you have Br and OH. So if you write down Br, okay, Br, OH, you say HOBr. Okay, so why I put HOBr, not BrOH? Because they mention it's going to be weak acid. So here, you see, this is strong acid, and this is a weak acid. Now, some of you wrote as BrCl plus H2O, okay, give you, okay, HBr, which is also a strong acid, okay, and then you write down as HOCl. Now, HOCl is also a weak acid. So do remember, we do accept, okay, both of this. Okay, so we can accept this, we can also accept this. So up to you, okay, which one you want to write. Okay, this one or this one. Now compare the polarity. Now, when they ask you to compare, you don't go and compare that this is going to be more polar than this. Okay, it's just going to tell that Cl2 is going to be polar. Okay, when they say compare, we know Cl2 is non-polar. You write down Cl2 is non-polar. Okay, they didn't ask you to explain, no need to bother to explain. Cl2 is non-polar, BrCl is polar. Don't go and write down BrCl is more polar than Cl2, even though that statement is correct, but it just indicates that Cl2 is polar. Yeah. So in that case, if you write down BrCl is more polar than Cl2, yeah, I will give you 0. Yeah, I will give you 0. Now, iodine, okay, is another halogen. Now you see another halogen. So iodine is another halogen. Its compound, sodium iodide, is used in treating thyroid disorder. Yeah. So here, okay, what physical properties of I2 and NaI are being expected? Yeah. So here you can answer anything. Yeah. If you want to refer to this also can. Without referring to this also can. But it must be physical. Okay, must be physical. Okay, so you can just say maybe if you're talking about NaI, okay, NaI maybe high melting point. Okay, they do not conduct electricity when in solid. Okay, but in molten, yes. In aqueous, yes. Okay, so high, I'll just put high melting point. Okay, no, doesn't conduct electricity. Okay, in solid form, okay, but can conduct electricity in molten or aqueous. Okay, or you mentioned about I2 is going to be solid. Okay, solid. Okay, which is going to be low melting point. Okay. Okay, and then does not conduct electricity. Okay, it's okay, accepted. Okay, but some of you, I think you would have written, like, for example, sodium iodide is used for treating thyroid. Okay, then you go and write down, okay, it's non-toxic and so on. Okay, do remember toxic and so on. Yeah, they are all chemical properties. Yeah, so this one I'll leave it to the teachers. Okay, but again, it's a physical property. Okay, so maybe if you're just referring from here, okay, then you say both of them are going to be solid also. Yeah, can. Yeah, can. But since it's 2 marks, okay, maybe if it is, you just say NaI and I2, they are solid. Yeah, then I will just give you 1 mark. Yeah, but again, you can get marks, okay, if it is physical property. Yeah, please take note. Okay, next, number 4. Okay, so you have compound E. Okay, it's shown below. It is produced by oxidation of lipids in the body. Okay, so name 3 functional groups of E. Okay, I have alcohol. Okay, alcohol. Okay, or you can say hydroxyl group. Okay, and then I have aldehyde. Okay, so aldehyde, and I will have, okay, this one functional group. Yeah, so it's going to be, I see double bond over there, alkene. Okay, don't go and put alkane, yeah, just because they have single bond over here. No, the moment you have double bond, it's already considered to be unsaturated, which is alkene. Yeah, so you just take note of that. Okay, name 3 is done. Yeah, so compound E may exhibit 2 types of isomerism. Explain this statement. Now, as long you can identify all those isomerism that can exist over here, some of you even pointed out, okay, you can bring the OH here, OH here. Therefore, okay, they will experience positional isomerism. It's okay, fine. Okay, you explain, okay, how you get positional isomerism. Okay, and then you can see the carbon over here is bonded to 2 different groups. Okay, and then the carbon over here is bonded to 2 different groups. Therefore, they can exist geometrical isomer. Okay, you explain why geometrical isomerism. Okay, you explain it's going to be cis and trans. Okay, why? Because the carbon bonded to the carbon double bond is having 2 different groups. Yeah? So they can exhibit cis and trans isomerism. And one more, okay, you just check, okay, whether there is going to be any optical isomerism. Okay, so I see here, okay, no optical isomerism, 4 different groups here. So no optical isomerism. So here carbon, you see different group, different group, different group, hydrogen. So there is going to be a chiral center. Yeah, so you can say that there is optical isomerism. Okay, why? Because there is going to be a chiral center. Okay, as long that you say positional, you take 1, okay, you will get only 2 marks. Okay, but if you ignore positional, you mention these 2, geometrical isomerism and optical isomerism. Okay, once you find out this, okay, these 2 are there, automatically you will get 3 marks. But if you don't find these 2 and then you do a combination, positional isomerism, structural isomerism, and then maybe 1 of it geometrical isomerism, you will get only 2 marks. Yeah, so please take note. Now, different reactions of E are shown below. So E will react, okay, with water, phosphoric acid, okay. Then I'm going to get this, okay. And then, okay, they will react, okay, with this, oxidize, and I'm going to get G. So E, okay, they are also going to react under reaction 3, and then you get something like this, okay. So here, okay, what we need to do is to identify, okay, we need to identify the type of reaction that is occurring in reaction number 1. So what is the type of reaction that is occurring over there? Okay, so this one, okay, is going to be known as what type of reaction? This one, I think, if you have the OH, okay, being there, okay, so here, okay, if you have this, okay, so the type of the reaction, if you want to put it over there, okay, it's going to be the answer. Yeah, if I just look at the answer over there, the answer is going to be electrophilic addition. Okay, electrophilic addition. And the answer over here for reaction number 3, okay, is going to be nucleophilic addition. Okay, nucleophilic addition. Okay. So if you look at it, okay, why nucleophilic addition over here? Okay, so basically you are having a compound that has this aldehyde group over there. Okay, so aldehyde, any carbonyl compound, okay, they will undergo nucleophilic addition, okay, with HCN, yeah, with HCN. That's the reason why you have the CN over here. So HCN, okay, and then the OH, okay, will come over here. So this is going to be the nucleophilic addition, yeah, for carbonyl compounds, okay, and that's going to be the reaction 3, yeah. So here from this reaction also I can see there is a double bond existing over there. So when I have this double bond over there, suddenly here there is OH, and then there's another addition of OH over there. This one just tells me that this reaction is going to be hydration. Okay, hydration, okay, where you put the carbon, double bond carbon, okay, so you have HOH, okay, so you will have the double bond broken, so you have H over here, OH over there, so something like that. So this one, hydration, this is the reaction where double bond, okay, is broken, so therefore it's an electrophilic addition. Okay, I do give answer, okay, if you mention hydration, okay, because they say type of reaction, so we can still accept, yeah, we can still accept this. Okay, now what test can be used, okay, to identify F, okay, from G? Now do remember, okay, F is going to be aldehyde, and F also has, okay, the alcohol group. Now the alcohol group, if you look in detail, okay, let's find out what type of alcohol is that. Okay, C, if I erase this, this is H. If I erase this, this is OH. This R group, another R group. Okay, that OH is going to be 2R group, so it's secondary alcohol. Okay, so I'll just put over here secondary alcohol over here, secondary. This one, if I erase this H, if I erase this OH, you can see one R group, another R group. This is also secondary, 2R groups. Okay, this is also secondary alcohol. And here, okay, if I look over here, okay, now, sorry, they are asking us to compare F, okay, F from G. Okay, what is G? So G, okay, is going to be, if you have the secondary, and then when you secondary alcohol and then you oxidize, you need to know what will happen. Yeah, what will happen. So basically, the secondary alcohol will be also oxidized to become ketone. Yeah, and then this one, okay, aldehyde can further oxidize to give you carboxylic acid. Okay, so what happens? Okay, there's no alcohol anymore. Okay, so if you have, if I'm just writing it down, if I have C over here, C, H, and then this one, this entire thing, I put CH3, CH2, 4, yeah. Okay, and then this one used to be OH, and then C, H, OH, CH2, CH, like this. What will happen? Okay, this one, okay, they are going to change into ketone. No more. They will change into ketone. No more. This one will get carboxylic acid. Okay. So here, okay, I am comparing, okay, something, okay, the G, okay, G has carboxylic acid and ketone. F, okay, they have secondary alcohol and aldehyde. So I want to identify them. Okay, can I use, what should I use? Okay, there is aldehyde, so you can use Phelan. Okay, Phelan solution. You can also use toluene. Okay, so tell us what will happen. Okay, Phelan is going to be blue solution, is going to become red precipitate when heated. Okay, toluene, okay, is going to give you silver mirror. So, okay, we can identify. Okay, now we can also, okay, because it's going to be some students write down 2,4-DNPH. The answer is wrong. Yeah? We will not accept, because 2,4-DNPH will react with F, will also react with G. You know, yeah. So we don't accept that. Some students, okay, they give answer PCl5. Okay, because PCl5, okay, they are going to give you steamy white fume. It's a test for alcohol, steamy white fume. Yeah. So if you have the HCl, okay, given off when it's going to be alcohol there, okay, then it's still accepted. So we do, I do accept PCl5, okay, to distinguish, okay, F from G. Okay, so you need to tell, okay, what will happen. Yeah, so if you're using PCl5, you will see steamy white fumes. Okay, then it's okay. Yeah, it's okay. Now draw the display formula of G. Just now I draw already. Okay, I just need to change this into display formula. Okay, so I'll just copy this, okay, and I put it here. And now I just need to change this into display formula. Okay, do remember display formula, you need to show everything, yeah. Okay, CH3, CH2 4 times, CH2, 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 CH2. Then C, double bond O, C, double bond O, CH, E, double bond O, O. Some of you just put like this very fast, yeah. Okay, do remember, I will deduct mark if you do this, okay. Display formula, you need to show all the bonds, O, H. You don't show this, okay, even everything correct, I will give you 0. Okay, it's not the matter of being strict, okay. You need to answer the question properly, okay. So since it's only 1 mark, okay, then I don't have any other choice, okay, to deduct mark. Okay, anyway, now comment whether or not, okay, compound G, okay, can form triiodomethane. Now compound G, okay, whether they can form triiodomethane or not, okay, you can form if it is going to be, if you have carbon double bond O, CH3 and R, okay, which G don't have. If it is alcohol, then we are going to talk about COH and then 1H and then CH3 and then another R. In this case, this is not alcohol. Okay, we are not going to focus on this. Okay, therefore the answer is no. If even you just say no, it's okay. You will get the full mark. Okay, so no. Okay, but if that it will be better if you can comment no. Okay, methyl ketone, yeah, or no, no. Don't have this structure, you can draw. Okay, in B. You explain. Now, what region could be used, okay, to make H? Okay, you want to generate H. Okay, so how? What region that you can use to make H? Okay, so what is H first? Okay, H is going to be something. Yeah, what region? Yeah, what is this? So this one, okay, you must react with HCN. Yeah. Okay, so region HCN. Okay. Or you can even say NaCN. Yeah, it's also okay. NaCN with acid, yeah, sulfuric acid. Okay, so HCN, yeah. Draw the mechanism for the formation of H. Okay, so I want to draw the mechanism for that. Okay, formation of H. Okay, compound E. So compound E, okay, straight away, I want to form, okay, this, okay. So maybe I'll just copy this first. Okay, I paste it here. Okay, to make our life easier, okay, you need to simplify them. Okay, so how to simplify them? So this one, okay, you know that, okay, before this, okay, they have, okay, this carbon over here. This carbon has hydrogen now, have OH, now have CN. So this one, okay, over here, okay, this one can be represented by R. Okay, so I'll just put down over here R equals to, okay, if I want to represent that, CH3, CH2, 4, CH, OH, CH, double bond CH. Okay. So if this is my R group, okay, so I have this, okay. So earlier, okay, do remember, okay, this is the reaction where, okay, this ACN, okay, it's actually reacting, okay, with it is reacting with a carbonyl compound, yeah, with a carbonyl compound, which is earlier supposed to be aldehyde, yeah. So what I do, okay, I will just put down, okay, the aldehyde earlier is R, okay. So I already put the R, okay, R, C, okay, double bond O, H. Okay. So this one, okay, so first what I do, okay, this one will go here, delta negative, delta positive. Okay. I need to put this, so no need to just keep on writing everything. Yeah. So once I put this, okay, they are going to react with this HCN, right? So HCN, okay. I just put HCN, okay. I know that this one, okay, it will become delta negative, okay, delta positive. So what happens now? The CN, okay, they will come over here. Or you don't want to show this first, also can. Okay, you can straight away put the CN dot dot minus. They come here. So when they come over there, so you will have R, C, O dot. Okay, and then you have okay, H, and then you have CN and 3. So this one, okay, they will react with this HCN. So this one is going to go here, delta negative. This is going to be delta positive. And this one will come over here, okay, making R, C, OH, CN, and then H. This one plus and dot. If you put all these steps, okay, I will give you the 3 marks. Okay. Next, okay, the last one. Okay. A chemist postulated, yeah, that compound E can be theoretically polymerized, forming poly E. Draw one repeat unit of poly E. Okay. So what is E? Yeah? Just now, I think we draw the E. Okay. So the E is going to be this R. Okay. I'll just still use this R. I just put over here, copy paste. R. This one's supposed to be the double bond. Yeah, we are focusing on the double bond. So maybe I just change the R a bit. Okay, this one CH double bond CH, then followed by this part is going to be CHO. Yeah, CHO. Okay, this is compound E. Yeah, this is E. I'll erase this part first. So if I want to show them, okay, one repeat unit, so I just put C, another C, H I put here, H I put here. This one, okay, will be this entire thing. Okay, so I can just put R equals to CH3, CH24, CHOH. Okay, so I just put this as R, no need to draw everything. And then here I just put C double bond OH, and like this, done. One single unit. Okay, this is going to be the answer. Yeah, that's it from me. Okay, thank you guys. Okay, hope you learn something from here.